Good day, grade 9 learners. Welcome to this last quarter of our challenging school year. I am teacher Eleazar, your guide in discovering the world of trigonometry. Are you ready? Join me then as we continue to explore, discover, and experience what Mathematics 9 has to offer this fourth quarter. Get your pen and your answer sheets and let's get going. Suppose you were asked to find the measures of an angle given the measures of the legs of a right triangle. How would you do that? Do not worry, trigonometry is here to help you. This audio video is created to help you understand and find out more about the triangle trigonometry.
Before we continue, let's get to know our objectives. First one, identify the 6 trigonometric ratios. And the second one, solve problems involving the 6 trigonometric ratios. The first part of this video lesson is the pre-assessment. This is to test your knowledge about our topic. Read each question carefully and choose the best answer. Write the letter of your answers on your answer sheet. Don't forget to pause this video while answering an item. First question. What do you call the branch of mathematics that deals with the relations between the sides and angles of a triangle? A. Algebra. B. Geometry. C. Calculus. And D. Trigonometry. Second question. In a right triangle, what do you call the longest side? A. Leg. B. Hypotenuse. C. Longer leg. Or D. Opposite leg. Third question. It is the trigonometric ratio of an angle's opposite leg and the hypotenuse of a right triangle. A. Sine. B. Tangent. C. Cosine. And D. Cotangent. Number 4. The trigonometric ratio of the acute angle of a right triangle defined by a cosecant is A. Hypotenuse over opposite. B. Opposite over hypotenuse. C. Hypotenuse all over adjacent. Or D. Adjacent all over hypotenuse. Number 5. The 6 trigonometric ratios are only applicable to what kind of triangle? A. Acute triangle. B. Right triangle. C. Obtuse triangle. Or D. Equilateral triangle. Number 6. If cosecant is the inverse trigonometric ratio of sine, then what is the inverse trigonometric ratio of cosine? A. Cotangent. B. Tangent. C. Cosecant. And D. Secant. Seventh, it is the mnemonic device used to easily remember the primary trigonometric ratio. A. Kausha-ko. B. Sukatoa. C. Kausotoa. And D. Toa-kausha. Number 8. Given the figure at the right, what is the opposite side of angle G? A. Side A. B. Side D. C. Side C. And D. Side G. Using the figure at the right, what is the measure of angle G if the measure of side A is 17 and the measure of the hypotenuse D is 23? A. Angle G is equal to 42.34 degrees. B. Angle G is equal to 73.91 degrees. C. Angle G is equal to 54.34 degrees. And D. Angle G is equal to 10.34 degrees. Number 10. What theorem do you usually use in solving the measure of the sides of a given triangle? A. Pythagorean theorem. B. Plato theorem. C. Suss similarity theorem. And letter D. Socrates theorem. Number 11. Triangle ABC is right-angled at B. If AB is equal to 9 centimeters and BC is equal to 11 centimeters, what is the tangent ratio of A to the nearest hundredths? A. 0.64. B. 0.73. C. 1.36. And D. 1.22. In the triangle PQR, what is the length of PQ? A. 1 centimeter. B. 5 centimeters. C. 9 centimeters. And D. 12 centimeters. In the triangle DEF, what is the measure of angle E? A. 16.59 degrees. B. 28.40 degrees. C. 41.57 degrees. Or D. 61.92 degrees. Question number 14. Triangle PQR is right-angled at Q. If P is equal to 30 and Q is equal to 60, what is the measure of angle R? A. 40 degrees. B. 55 degrees. C. 60 degrees. Or D. 65 degrees. And the last number for the pre-assessment, find the value of C to the nearest unit. A. 19.58. B. 21.15. C. 23.10. And D. 24.01. Let's check your answers on the pre-assessment. The answers are 1D, 2B, 3A, 4A, 5B, 6D, 7B, 8D, 9A, 10A, 11D, 12B, 13D, 14C, and 15A. And what's your score? Anyway, on this activity, it is not expected that you will get a very high score.
The next part is recalling the concepts you need in this topic. Every concept presented in this part is essential on our next lesson.
We begin by having a short review with the different parts of a right triangle. Considering the figure, right triangle ACB with sides A, B, and C. Angles A and B are acute angles. Side A is the shorter side. Side B is the longer leg. And side C is the longest side, or also called as the hypotenuse. Now it's your turn. Kindly do the activity for mastery of these concepts. You may pause this video while you are answering the activity. Let's check your answers. The answers are the following. Were you able to get the correct answers? If not, kindly study the answers given on the activity. There are also other concepts which we will use in this module. The first one is adjacent side, which means the side next to the reference angle in a right triangle. In a right triangle ABC with sides X, Y, and Z. The adjacent side of angle A is side Z, and the adjacent side of angle C is side Y. The next concept is the opposite side, which means the side across the reference angle in a right triangle. So in our right triangle ABC, the opposite side of angle A is side Y, and the opposite side of angle C is side Z. I think you have learned something from what we have just said a while ago. So kindly do this activity and don't forget to pause this video while answering. Let's reveal the answers. So, how was your score? Was there an improvement?
The next part is the discussion of the lesson. All illustrative examples about our lesson will be presented here. Focus is the key for you to understand the topics.
Let us now start discussing about the 6 trigonometric ratios. In this lesson, always remember SOHCAHTOA. Let us consider right triangle ACB letting angle B as our reference angle. A is the adjacent side of angle B. B is the opposite side of angle B, and C is the hypotenuse of the right triangle. What is SOHCAHTOA? So is used for sine, ka is used for cosine, and TOA is for tangent. Let us start first with sine. So, using B as our reference angle, sine of angle B is opposite all over hypotenuse. That came from SOH or SOH. The opposite of angle B is side B, and the hypotenuse of the triangle is side C. The next ratio is the cosine, or we are going to use K, which is adjacent all over hypotenuse. The adjacent side of angle B is side A, and the hypotenuse of the triangle is side C. The third ratio is the tangent. So we are going to use TOA, or that is opposite all over adjacent. The opposite side of angle B is side B, and the adjacent side is side A. The other three trigonometric ratios are determined by getting the reciprocals of the first three ratios. For sine, which is opposite all over hypotenuse, its reciprocal is cosecant. When we say reciprocal, that is interchanging the positions of the numerator with the denominator. So as you can see, the numerator for sine is opposite is the denominator of cosecant. Next is the cosecant. Its reciprocal is secant. And the third one, tangent. Its reciprocal is what we call the cotangent. Let us have one example on the SOHCAHTOA. Using triangle ABC and angle B as the reference angle, the six trigonometric ratios are: for sine of angle B, that is opposite side, which is side B all over the hypotenuse, and its reciprocal cosecant, that is C all over B. For cosine of angle B, that is adjacent all over the hypotenuse, and its reciprocal secant is C all over A. The tangent of angle B, which is the opposite side all over the adjacent, and its reciprocal is cotangent A all over B. Are you still confused with SOHCAHTOA? Practice to clear your confusions, so do this activity on your own. Let's reveal the answers. So these are the answers from your activity a while ago. I hope you were able to get correct answers. If you're still confused, you can always go back, because you cannot cope with the next lessons if you did not yet master SOHCAHTOA. Let's take a look at some examples in applying the concepts you have just learned. Given right triangle ABC, identify the six trigonometric ratios at angle A. Or in other words, on our triangle BCA, our reference angle is angle A. The first ratio is sine, using SOH. Okay, so our angle is at angle A. Its opposite side is side A, all over hypotenuse, which is C. The value of side A is 3, and the value of side C is 5. Therefore, the ratio of sine of angle A is 3/5. Now, it's your turn to find the other 5 ratios. The next ratio for cosine of angle A is 4/5. The ratio for tangent of angle A is 3/4. For cosecant of angle A, that is 5/3, or getting the reciprocal of sine. Secant is 5/4, or the reciprocal of cosine. And cotangent is 4/3, or that is simply the reciprocal of tangent, which is 3/4. Second example. Triangle BCA is right-angled at C. If C is equal to 23 and B is equal to 17, find the measure of angle A. Since the given side B is the adjacent side of angle A and side C, which is the hypotenuse, we are going to use Ka. That is, cosine of angle A is equal to the adjacent side, which is B, all over the hypotenuse, which is C. The next step is to substitute B, which is 17, and C, which is 23, in your equation. Then after which you're going to divide 17 by 23, which results to 0.7391. To find the measure of angle A, you're going to use a scientific calculator. In your calculator, you press Shift, then cosine, then 0.7391, and then finally press equals. The number that should appear in your calculator is 42.34, or in other words, the measure of angle A is 42.34 degrees. For our third example, in triangle YOU, OY is equal to 12 and angle U is equal to 48 degrees. Find side UY. So on this problem, one side and an angle is given. Then we are asked to solve for another side of the triangle. So on this problem, our reference angle is at angle U. Since OY is the opposite side of angle U and YU is the hypotenuse, we will be using SO, or that is simply sine. So that is, sine of angle U is equal to the opposite side of angle U, which is OY, all over the hypotenuse UY. Substituting the two given on our equation, we have sine of 48 is equal to 12 UY. And on this process, you're going to use cross multiplication. So multiply sine of 48 with the unknown UY. And the result is this equation. Then after which, you're going to divide both sides of the equation with sine 48. And again, in your calculator, you're going to press 12, then the division sign, then the sign, then 48, and then finally press equals. So the measure that we are looking for, UY, is equal to 16.15. Our final example for this lesson. Given that angle B is equal to 65 degrees and A is equal to 8, find the 6 trigonometric ratios of the triangle at angle B. So to find the 6 trigonometric ratios, we need to find the measure of all sides of the triangle. To solve for the unknown sides B and C, we are going to use the given A, which is 8, and then the measure of angle B, which is 65. You may choose to solve B or C first. Let us first find the value of B, or the measure of side B. Since A is the adjacent side and B is the opposite side of angle B, then we will use TOA, or that is simply tangent of angle B is equal to side B all over side A. Substituting the values, we have tangent of 65 equals B all over 8. And on this process, we are going to use cross multiplication. Multiply tangent of 65 with 8, and that results to this equation. In your scientific calculator, again, you press 8 and then tangent of 65 and then press equals. Therefore, the value of B, or the measure of side B, is equal to 17.16. We already have the value for A and B. Our next step is to solve for the measure of side C. When two sides of a right triangle are given, we may use the Pythagorean theorem to find the third side. The formula for the Pythagorean theorem is C equals the square root of A squared plus B squared. Substituting the values of A and B in our Pythagorean theorem, then evaluating the numbers. You may use a calculator to evaluate the numbers. Therefore, the value of C, or the measure of side C, is equal to 18.93 units. Since we already have the measure of the 3 sides of the triangle, we can now identify or determine the 6 trigonometric ratios of the triangle at angle B. Trigonometry is also applied in other subject areas. For instance, in science, it is applied in projectile motion. It is also used in navigation in order to pinpoint a certain location. Trigonometry is also used in marine biology. It is used to find the measures of angles of depression and angle of elevation. Architects also use trigonometry to calculate roof slopes, light angles, ground surfaces, structural loads, and heights of structures.
Did you learn something from the discussions and the illustrative examples? I do hope so. The next task is to test the skills you have learned from this lesson.
Kindly do the activity and do not forget to pause the video while answering. This activity is a summary of our lesson. So kindly do the activity. Let us see if you can still remember your trigonometric ratios. Let us go deeper with the skills and concepts you have learned from this lesson. I would like you to solve the two problems posted, and please show your complete and neat solution in your answer sheets. This is your last activity. This will measure your learnings all throughout the module. And I am hoping that your score on this post-assessment is much higher than that of the pre-assessment. You may start. First question. What do you call the branch of mathematics that deals with the relations between the sides and angles of a triangle? A. Algebra. B. Geometry. C. Calculus. And D. Trigonometry. Second question. In a right triangle, what do you call the shortest side? A. Shorter leg. B. Hypotenuse. C. Longer leg. And D. Opposite leg. Third question. The trigonometric ratio of adjacent leg and the hypotenuse of a right triangle is A. Sine. B. Tangent. C. Cosine. And D. Cotangent. The trigonometric ratio of the acute angle of a right triangle defined by a cosine is A. Hypotenuse over opposite. B. Opposite over hypotenuse. C. Hypotenuse over adjacent. And D. Adjacent all over hypotenuse. The six trigonometric ratios are only applicable to what kind of triangle? A. Acute triangle. B. Right triangle. C. Obtuse triangle. And D. Equilateral triangle. Number 6. If cosecant is the inverse trigonometric ratio of sine, then what is the inverse trigonometric ratio of tangent? A. Cotangent. B. Tangent. C. Cosecant. And D. Secant. Question number 7. What is the mnemonic device used to easily remember the primary trigonometric ratio? A. Kausha-ko. B. Soka-toa. C. Kaso-toa. And D. Toa-kausha. In triangle ADG, what is the side adjacent to angle theta? A. Side A. B. Side D. C. Side C. Or D. Side G. Number 9. What is the measure of angle G if the measure of side A is 10 and the measure of the hypotenuse D is 15? A. 44.34 degrees. B. 48.19 degrees. C. 54.34 degrees. Or D. 40.34 degrees. Number 10. What theorem do you usually use in solving the measures of the sides of a given right triangle? A. Pythagorean theorem. B. Plato theorem. C. Sas similarity theorem. Or D. Socrates theorem. Question number 11. Triangle ABC is right-angled at B. If AB is equal to 3 centimeters and BC is equal to 5 centimeters, what is the tangent ratio of A to the nearest hundredths? A. 2.64, B. 3.73, C. 1.67, and D. 1.22. In the triangle PQR, what is the length of PQ? A. 13.23 centimeters, B. 5.28 centimeters, C. 9 centimeters, or D. 12 centimeters. In the triangle DEF, what is the measure of angle D to the nearest degree? A. 26.59 degrees, B. 28.07 degrees, C. 41.57 degrees, or D. 31.92 degrees. Triangle PQR is right-angled at Q. If P is 30 and Q is 60, what is the measure of angle P? A. 20 degrees, B. 65 degrees, C. 30 degrees, or D. 65 degrees. And the last item, in item number 14, what is the measure of angle R? A. 60 degrees, B. 55 degrees, C. 30 degrees, or D. 65 degrees.
That is all for this video lesson. Thank you so much for your time and your participation. Once again, this is your teacher Eleazar signing off.